Right, so thank you very much, Tom. I'm going to talk to you about two things today. Large BGP communities, in which I had approximately 15 minutes at the last UKNOF session in January to try and rush through, and something called shutdown communication that I shall expand upon as we go through this presentation. I'll start with large BGP communities in a slightly more relaxed fashion. And to do that, I need to start with standard RFC 1997 communities. And when I gave this talk the first time, I asked for a show of hands on who were familiar with or used regularly 1997 communities, and most of the audience put their hands up, so they need really no explanation. One of the examples that I wanted to give last time was that when this was standardized, one of the examples that were given, and you can still find in the RFC, is that a community can be placed on a route to use to signal that the NSFNet participant has accepted the use of the acceptable use policy. So, along with this RFC, another one was published in 1998, which talks about the usage for such communities, and I shall come back to that after explaining what large communities are and what's happening with them. So, what's the problem that we're trying to solve here? The problem is that since the advent of 32-bit autonomous system numbers and RIPE NCC assigning these things by default unless you ask for 16-bit since 2009, the operators with 32-bit ASNs have had a problem in that they cannot encode their autonomous system number in the start of the community. Yes, that's right, there are only 16 bits, and trying to fit 32-bit ASN into that namespace does not work. There have been a number of solutions to this over the past 10 years. None of them, though, have really solved the problem. One of which is extended communities you might find in MPLS VPNs. They can't be used on the internet, and they don't solve the problem as eloquently as large communities do. We needed a solution, and we had nothing until now, really, that I would have considered. So the solution is here, and in January this was a draft that had gone through last call. It has now been standardized as RFC 8092. It went from draft publication to an RFC in just 7 months. The final standard plus implementations and a number of pieces of tooling have been developed as well, and this is something that you can test and deploy in networks now using new technology. It is reasonably impressive. The picture there is a cake that was made for the in NTT celebrating the publication of the RFC. So how do large communities work? Well, we have three 32-bit values represented as in 96 bits. There's the autonomous system number, which is 32 bits, and then two further 32-bit fields, one of which we call the action, or the operator-defined value for the action, the other of which is the operator-defined value for the target, or the thing that you want to affect. The canonical representation of this is me, action, and you. As a result of having 32 bits in the autonomous system number, we now have a unique namespace for either a 16 or a 32-bit ASN. There are no namespace collisions. You do not have to do any overloading. In the planning for this, there have been a number of things to take into account. There is a chap represented here. This is Frederick Korsbach. I'm not sure if I'm pronouncing his name correctly. He wanted large communities standardized for Christmas. He didn't get it quite in time, but this just shows how important this has been for the community as a whole. So to give you an example of doing this, I talked before about RFC 1998. When that was published along with RFC 1997, there was, even back in those days, in the 90s, there was no big event to go and convert over to these types of communities. They were seen as an additional way of signaling information to peers. We're still recommending the use of the RFC 1997 well-known communities, such as no advertise, no export, etc. This is about extending policy and developing new capabilities, not switching, and that's something that I want to point out in the examples that I'm about to show. So here we are giving a number of examples of things that are being used in various operators, and in one of these examples we are making reference to communities that are published, or community structures that are published by the INEX, who have actually, on their root server, which is Bird, I got that wrong last time, have deployed large communities code, are running it, and have a set of large communities you can use to signal the root server as to what you wish to do. In these examples, we've got some various action communities such as don't advertise or modify local preference, And we're showing that on the left-hand side in the first column how this currently looks with the existing standardized 1997 communities, and how this can be adapted with large communities to make things clean. If you look at the last two examples, for example, the signaling of whether a route was received from a peering partner or a customer, you saw we have to overload the last 16 bits with a value. So whereas the 400s was used to signify this was a route being received, the 410 and 420 would represent the peering partner or the customer. In the case of the large communities, we can cleanly separate this out with 400 as the action and 10 and 20 as the target of what's to be affected. Again, this shows the lack of collisions in both of these places, and the fact that we can use 32-bit communities, 32-bit ASNs rather, in the autonomous system field, the first field of the large community. So, I talked about RFC 1998, and that's a usage and deployment document. So there's an equivalent of this currently going through the GROW working group in the IETF. It's called draft-ietf-GROW Large Communities Usage, and the fact that it starts with the words draft-ietf-GROW means that it's something that's currently been adopted and is something that the working group have taken on as a document of their own. It provides many examples and inspirations for use of these communities, and I shall cover a few of these in the following slides. So to separate the types of examples out, informational communities in the GROW document, there's an example using ISO 3166 country codes and something called M49 geographic region codes. These are, I'll show you these in a minute, but these allow you to encode some of this information in the community. It's easy to just show you an example of what this means. I should have read UN, by the way, not UM. So here on the left-hand side, using the 3166 country IDs, we can represent 3 countries, the Netherlands, Japan, and the USA. In terms of the regions, we can represent Africa, Oceania, Eastern Asia, and Europe. And in the target field, we can represent relations, internal, customer, peering, transit, so on and so forth. So, for example, here, given 644971528, 644972150, and 6449732, we can say that this was a route learned in the Netherlands, in Europe, from a customer. And we've encoded all of that using this existing system. We can also talk about geolocalization. In another example given, we can take UK postal codes. There's a scheme known as base 36, where you can encode a string using a set of characters from the standard Latin alphabet, plus the series of numbers, and you can turn that into a decimal. So we can take a UK postal code, remove the white space, turn it into a decimal, and represent, and use a large community to represent the fact that some equipment is located at this postal code. We can also do this with GPS coordinates using a scheme known as geohash. There's a link to that in the slide deck. And we can take a location and we can encode it with a reasonable degree of precision and convert that into decimal. And we can say that a piece of equipment is located at these coordinates, all using large communities. And then there are action communities. So, for example, to request that a route be treated in a particular way, how the route's propagated, how traffic is influenced. We, in these examples, define the global administrator to be the ASN that wants this functionality. And a good use of this is to take allow providers to make actions on behalf of the customer. So a customer requests that traffic is treated in a certain way. The provider provides a large community scheme in order to influence that traffic. So the examples given here: selective no export, for example, selective prepending, selective local preferencing. So getting started, 2018 is the year of large BGP communities. There's preparation, testing, training and deployment that we're requesting everybody does. If you start now, when your customers come and ask you for it, you'll be ready. There are a number of implementations and analysis and ecosystem tools. There are a number of presentations on the topic that many of us have given at industry events, and there's lots of documentation for the implementations that currently exist and examples that are also published on the large bgpcommunities.net site. There are also some beacon prefixes that currently exist on the internet. Go and have a look at them. There's a /24 of v4, /48 of v6, and they both are marked with the BGP large community 15562:1:1. Hopefully you'll have a box that may not, that if it doesn't understand, it will be able to at least show you the raw data. An example here is taken from Cisco, showing the unknown transitive attribute and the hex encoding of the value. Where you do have something that understands it, for example, bird, you can see the large community displayed below. And there's just an update on implementation statuses. A number of the large vendors either have code in beta or have something planned to ship. Most of the software vendors have done the work already. There are some outliers, such as Microtik, who refused to implement until an RFC was published. Now the RFC is published, we're not sure whether they will implement or not. There have been a number of people chasing them, and a number of feature requests made by customers. So if you don't see your vendor here, or even if you do see your vendor here, go hassle them, because this is something we really need. And now it's standardized, there's very little reason why they shouldn't do it. Same with tools and ecosystems. So, for example, TCP dump and Wireshark dissectors, a lot of this work's already been done. These tools are essential in debugging issues that you have or may have with interoperation. So we're really glad to see this work's had been done already prior to standardization. That's it for me on large communities, and I'd like to ask for questions at the end on both of these so that I can move to shutdown. Can someone give me an indication of how much time I've got left, since I don't have a clock? A lot. Excellent. Okay, so shutdown communication. Great. So communication can be a challenge. Of course it is. There have been a number of efforts to use BGP as a control plane to communicate information between peers. A good reason for this is the fact that when you peer with a number of people over a shared medium, such as an internet exchange, whenever there are maintenance events, there may be emails that circulate informing you that a peer is going to take a session down at a particular time. But a number of these emails either don't get read, or they get read but not understood, or they don't get read at all and they're put into an automated system or a maintenance calendar that's then ignored. And then at some point the session goes down over the exchange, and then a flurry of emails start to the exchange's operational list saying, hey, we've noticed this session go down, what's wrong with it? We get this all the time. We'll notify people in advance we're taking a port down on an exchange, and we'll still get contacted by people. And the culprits here are really large networks that should know better. And you know, I'm quite horrified to find sometimes I get emails from these people saying, hi, we noticed this session's gone down. We've opened a ticket about it, and we're now chasing you about this ticket, and we want an update on it because we're breaching some internal SLA on it. So you know, it's really quite disturbing. So the concept of communicating in band over the BGP session has been around for a long time. Unfortunately, it hasn't really moved since 2002. There have been 4 drafts, 2 of which I've been involved in, that have died for various reasons in the standardization process. The first of which we call BGP Inform, it wasn't adopted. And then the second of which, that was called BGP Soft Notify in 2005, also wasn't adopted. I then was involved in a draft called Advisory that some of you may remember me talking about in 2009, that was adopted, but we decided to transform into something else called Operational Message. And then Operational Message was adopted in 2012, but didn't progress, so that died as well. So right now we have no real means of communicating over BGP, although that's actually not true. I don't know how many of you are familiar with the RIPE RAS project and all the data and interfaces that have been co-opted now into the RIPE STAT project. But if you, one of the things that it does do is monitor the stability of prefixes on the internet. And if a prefix flaps, you know, it will draw you a little line on a graph for where this prefix has become visible and then become invisible. And if you coordinate the flapping of these prefixes right, you know, you can draw a picture with it, as NTT have done. So yes, it's true, there is a way of communicating over BGP. Unfortunately, it takes a very long time. I think we're still waiting for this CAT to be completed. I don't know when it will be. So we want to get messaging back on the table, but the problem has been traditionally getting things through the IETF. And I want to quote you something that a large vendor told me in sort of this process. They said the IETF has become a dumping ground for ideas. There are too many Researchers in the IETF now, we don't implement every RFC anymore. The demand complexity ratio is what counts now. So we need something that's simple, something effective, and something easy to implement. So this represents the latest thinking. We call it shutdown communication. It's fifth iteration, and it's a combination effort between NTT, Cisco, and Juniper. And what's unique about this is the fact that we actually reused the existing space at the end of a cease notification. So the cease notification is a piece of signaling that goes out when a session is shut down. If you have a chance to shut a session down administratively, we'll send, or the standard says you should send a cease notification. And the cease notification permits us to put some text at the end of it, and that's exactly what this draft capitalizes on. We encode some text, and here's an example as implemented in, I think, in OpenBGPD. We're taking a session down, and we're putting a message. We're saying, this is, here's a ticket number, we're upgrading our OpenBSD, we're going to be back in 30 minutes. And the peer gets the cease, and also gets this message, and has the chance to render it. And this is a very important idea. So there are a number of implementations of this so far. We have OpenBSD and its OpenBGPD. We have GoBGP, which is a BGP implementation written entirely in Go. We have ExaBGP, of course, a BGP implementation written in largely Python. And we have some tools, PMACT and Wireshark, that understand the message. But we also have a sort of commitment from the vendors to implement this in mainstream software, simply because of its simplicity. Both Cisco and Juniper have implementations of it, and Bird is on the way, and Nokia have also said they're going to do it. And the IETF status for this is almost at last call. I think when I say almost at last call, a mail went out saying, shall we take this to last call? And then the draft was revised at the last minute. So it's planning to go to last call any minute now. And yes, of course, Unicode works as well. You can send an emoji poo if you so wish. I'm not sure how the other side would choose to interpret that, but you can do it. So I'd like to take any questions about either large communities or the shutdown communication, being that I've got just slightly under 10 minutes left.
No questions at all. What's going on?
No one's interested in the emoji poo, I take it. No?
We
okay.
are doing very well on time.
Thank you very much.
Thank you, Dave. Cheers.